All right, this problem reads, at takeoff, a commercial jet has a 60 meters per second speed. Its tires have a diameter of 0.85 meters. How many revolutions per minute are the diameters rotating? What's the centripetal acceleration at the edge of the tire? What force must a determined little bacterium cling to that rim if we had a bacterium on the rim of that tire? What force must it use to cling to that rim? And then what's the ratio of this force to the bacterium's weight? Just to do some ratios. All right, so if we have a tire rotating and the plane is moving at 60 meters per second, then that tire is rotating with a linear velocity at the edge of that tire at 60 meters per second, okay? So the first thing we want to know is how many revolutions per minute. Well, that's a form of angular velocity. And we know that the angular velocity, so for part A, the angular velocity is related to the tangential velocity, such that that tangential velocity is equal to the angular velocity times the radius. So we're given that the diameter of this wheel is 0.85 meters. So that has a radius of equal to 0.425 meters is our radius. So we can use this relationship. 60 is equal to omega times 0.425. And if we use our handy dandy calculator, we find that omega is 141.2 radians per second. So when using this relationship, omega is given in radians per second. And we're interested in revolutions per minute. So we need to convert our radians per second to revolutions per minute. So we know that 141.2 radians per second. We know that there are 2 pi radians in 1 revolution. So that's going to get rid of my radians unit. And I know that there are 60 seconds in 1 minute. So that will cancel my seconds unit. And we find omega in revolutions per minute of 1348 revolutions per minute. So first we have to determine using our relationship from angular velocity to linear velocity. And then we can convert that angular velocity to radians per second to revolutions per minute. Okay, the next is what's the centripetal acceleration at the edge of the tire? Now remember, there are 2 ways to determine, so this is for part B, there are 2 ways to determine centripetal acceleration. We can use linear velocity and calculate it v squared over r, or we can use angular velocity, which is omega squared times r. And in this case, we have both pieces of information. We have omega in radians per second and the radius, and we also have the speed squared and the radius. So we actually could do either one of these 2 equations. In our case, it does not matter for us since we've already determined it. And so we'll just use this lower equation this time. The centripetal acceleration, omega, is 141.2 squared times my radius of 0.425 meters, and I get a centripetal acceleration of 8,470 meters per second squared. So that is part B. And if we would have used 60 meters per second with that radius, we would have ended up with the same thing. All right, part C says that with what force must a determined bacterium cling to that wheel? Well, if it's staying attached to that wheel, it's feeling a centripetal force. And we know that the centripetal force, this is part C, the centripetal force is the mass times that centripetal acceleration. We only have one force acting to cause that centripetal acceleration, and we know that centripetal acceleration, so we can determine the force by taking the mass of 1.00 times 10 to the minus 15th times my centripetal acceleration of 8,470. And when I do that, I get a force of 8.47 times 10 to the minus 12th newtons. So using my relationship that the centripetal force is the mass times the centripetal acceleration, we can determine the force that that bacterium has to hold on. And the last part says, what's the ratio of that force to the bacterium's weight? Well, for part D then, we need to know the force of gravity, which is the weight of that bacterium, which is the mass times gravity. That mass again is 1.00 times 10 to the minus 15th kilograms times 9.8. That gives us a gravitational force of 9.8 times 10 to the minus 15 newtons. And if I take the ratio of these two, so the force of gravity as a ratio to the centripetal force, I find that gravity is equal to the centripetal force. We want to take the ratio of this force, the centripetal force, to that of gravity, the other ratio. So we take the centripetal force divided by the force of gravity to do that. So that's our 8.47 times 10 to the minus 12th divided by 9.8 times 10 to the minus 15th. And we find out that the centripetal force is 864 times that object's weight, so that bacterium's weight. So a force of 864 times its weight would be required for it to cling to the edge of that rotating tire if the airplane is going at 60 meters per second. All right, so determining the rotational velocity, just looking at the relationship between linear velocity and rotational velocity. Converting it to revolutions per minute. We've been doing a lot of that kind of practice in this kind of collection of playlists. The acceleration, centripetal acceleration, can be found two different ways. We've chosen one of those two. It would have been the same the other way. Recognizing that that centripetal force then is the mass times the centripetal acceleration, and then just looking at the ratio of the weight to that centripetal acceleration. All right, good job.